Hey guys, today we're going to do a lesson on probability, specifically probability in our lives. Now, when we're talking about probability, a quick definition, probability is the chances of an event happening. And we're going to look at a bunch of different events, and we're going to look at how probability is calculated in different scenarios, and that's mostly what we're going to do for this unit. So first I'm going to talk about why is probability important and why should we learn it, and just how prevalent it is in our lives. Like, we see it a lot more than maybe we think. Where have you seen probability in your life? So take a second, pause the video, and you can fill out where you might have seen probability in your life. Okay, when you come back, some of the things you might have thought about might have been weather. They talk about like the probability of it raining or probability of precipitation. Casinos, specifically card games, or roulette, sports, such as hockey and the save percentage, batting average, lots of different sports examples. What else? You may have also thought a lottery. In the news, they use that a lot. Couple different examples. If you thought of more, that's perfect, but that's just to kind of get us started. I've thought of a couple. Let's look at this activity, and I'm just gonna have you can think about it. I usually do this in my face-to-face classes, and I have students work together. But think about your answers to these and what kinds of questions that you might have when you're trying to answer this. Like 60% chance of rain tomorrow. Would you cancel your plans to go for a hike? Think about what you might answer to that. Some people would say, yeah, because it's 60%, I don't want to get wet and I don't want to be rained on. But other people might think, if they're really into hiking, oh, it's only 60%. I'll just make sure that I plan for that. So it's kind of interesting how people will look at the percentages and think differently based on what's happened in their life or what they're more interested in. So do that activity if you can. We often express probability or likelihood of something happening, such as you might say probably. It'll probably happen, or never. Like, that's never going to happen. Always. I always get perfect on my math test. Not likely. Likely. Your mom may have said it to you, maybe. Like, can I go to the park later? I don't know, maybe. And then you decide whether or not your mom is actually going to let you go. Stuff like words like that will express probability. We can also use numbers, like percent. So you might be like 100% or 50% chance of something happening. They may use decimals. Like 0.25 or 0.35 to express your percentage as a decimal. Fractions. Like, my chances are to get a heart is 1 1/4. My chance to roll 1 on a dice is 1 in 6, stuff like that. And then also there are ratios. So like 1 to 2. So the Leafs have a chance of winning 1 every 2 times. Stuff like that. I hope it's not that bad. I'm sorry for those Leafs fans. But yeah, you can look at it all those different ways. And all of those are actually a way to show probability. Now, they also will put them in, because most probability lies between the numbers 0 and 1. So what they do is they make these like number lines. So you can see where 0 is absolutely impossible, like it's never going to happen. And you give it a 1 if you're absolutely certain that it's always going to happen. It's for sure going to happen. The rest of the times your probability of the event will lie in between those numbers. So in this example here, we see that they're all decimals, 0.1, 0.2, 0.3. So it lies between 0 and 1. And then down here, it translates into our percentages or our fractions. So 0.2 is also 20%, so 1 or 1/5. So you can see that it's in decimals, percentages, and fractions. And then you can predict where you're going to be based on this little like number line. I also have a little joke there. Did you ever hear the joke about the statistician? Probably. Sorry, guys. I'm really corny when it comes to math jokes. For question B. Whoa. So moving on to the next page or the back of the page, depending on how you printed it. I've got 2 examples here. I'm going to go through them. First example, by March 2006, 52% of Canadians had cell phones. In Sweden, more than 90%. We can highlight these if we want. 52% Canadians, 90% Sweden. Ottawa and Stockholm are the capitals of these countries, have similar populations. Suppose you are walking down the street in Ottawa or Stockholm. In which city are you likely to see more people using cell phones? Use a probability line to explain your answer. So if we use a probability line for this, I'll just set it up 0, 1, 0.5, that's 50%. And then we can kind of figure out where each of those countries might be. So Ottawa, 52% of Canadians, so we're going to expect it to be somewhere here. And Sweden says 90%, so that's somewhere here, or Stockholm there. And you'll notice that the closer it is to 1, the more likely we're going to see it. So in which city are you likely to see more people? Likely to see more in Stockholm, just because it's closer to that 1 value or closer to that 100%. Nice, easy, simple little example. Moving on to the bottom one here. Let's talk about this one. The table shows how many Canadians watch 2 television shows in 1 week. So we've got show A here and show B here. And then it's been broken down into different age groups. Which of the 2 shows is a 23-year-old selected at random more likely to have watched? So if you look at between the 23-year-olds are in this 18 to 24 thing, and there's way more people watching show A than there are show B in that category. So we would say show A. B, which show had more viewers? Explain how you determined your answer. The way to figure this out is just to add them all up. So take a second, add up all in each column, and then we can figure out how to, which ones were better. So I'm going to pause. I'm going to figure it out. Okay, so I added them all up. And for show A, I got 9 963,000. And for show B, I got 1,615,000. So for question B, suppose which show had more viewers? Show B had way more viewers. Suppose a person watching show B is selected at random. What is the probability that the person is in the 50 to 54 age group? So if we look at the 50 to 54 age group, we get 400,000. And so what you're going to do is to show that probability is to take that number that are watching in that age group and divide it by the total. And just the total of show B. So 400,000 divided by 1,615,000. I get 0.2476. So approximately 25% if we times it by 100. Suppose you are a media planner buying advertising time for a new MP3 player. This question's kind of old. Who uses an MP3 player anymore? But anyways, during which show would you rather place an ad? Explain your reasons. So when we have questions like this, I'm just going to tell you guys that sometimes it's not about getting the right or the wrong answer for this. It's about, are you giving me a good enough reason as to why you're going to put that there? So for this one, some students will say, hey, I'm going to put it in show A because it looks like show A has the most viewers between under 18 up to 34. So it is a very young audience, and that's who would more likely to buy the MP3 player. I also have had other students say, well, no, I'm going to buy the third, place it in the 25 up to 55 plus range because those are parents and grandparents, and they're more likely to buy them for their kids. So as long as you have a good answer, both of those answers are reasonable, and both of them I would give marks for because you've given me what you think, but also given me a reason why, and a very valid reason why. E, would your answer to part D change if the product you are advertising is a video game? And some people will say, yes, it will. And some people will say, no, it's not. But again, this is a similar question. And I would expect like a similar type of answer. As long as you're giving me an answer with a reason, I will mark it right, as long as the reason is like reasonable and it makes sense. Okay. There's a practice sheet just like normal and a quiz that I will be putting up. So have fun with this one, guys. Bye.